Welcome to HelpYourMath.com. In today's video, we're going to be covering the quotient rule of exponents. And this is usually known as the subtraction rule when you're subtracting the upper numerator's power by the denominator's power. And so, in this case, we have a good variation of problems in which what we're going to do is we're going to try to work out every detail. And some of these are repeating because I'm going to do these in two different ways. And one way we're going to do the original rule in which we're going to use the negative power, the negative exponent rule. And others we're going to use a different rule which is a little bit more advanced for those of you who are a little advanced already or want to advance yourselves to another level, all right? So the rule is whenever you have two bases that are the identical bases and they have different exponents, to simplify these, what we want to do is take the subtraction of the exponents. And so for problem 1 here, what we're going to do is we're going to say x to the 7th divided by x to the 3rd is the difference of the exponents as a numerator. So we have x to the 7 minus 3. And the resultant exponent is your answer. And so when I do 7 take away 3, I get the value of 4, and my base is still x, and I get x to the 4th power. Now, because the result is not a negative exponent, I don't have to follow the principles of the negative exponent rules. But in the case you do get a negative exponent, you're going to want to carry out those principles too. So if you need help understanding the negative exponent principles, you can also watch our video that covers the negative exponent. All right, so let's take a look at a problem that deals with that now. So here we have x to the 3rd power divided by x to the 5th power. And in this problem, what we have is a denominator with a greater power than the numerator. Here we saw the 7 was greater than 3, so the result is positive. But 3 take away 5 is going to give us a negative. So 3 take away 5 is going to be x to the negative 2nd power. And using the negative exponent rule, what we do is we reciprocate this, which it goes to the denominator with a positive power. So we get 1 over x to the 2nd. Now this isn't the only way that we could solve a problem like this, being that we notice from the beginning that the power in the numerator here is greater than the denominator. We get a positive. When the numerator is lesser than the denominator, we know it's negative, so instead of subtracting as a numerator term, we can just subtract them as a denominator term. And this is a bit more advanced and a little bit difficult to get adjusted to, but once you get the hang of this, it works pretty well for you because it cuts a step out. So here we're doing x to the 5th, take away 3 in the denominator. And this then just gives us 1 over x to the 2nd right away. So it's a bit of a shortcut, but it takes some getting used to. So I wouldn't just force this on myself. I'd actually work the long way until you get used to it. And once you start getting the hint of when the positive and the negative occurs, you can start advancing what you're doing with your math, little by little, all right? So let's move on to number 4 here, where we're dealing with one negative exponent and a positive one when we're doing these differences. So here we have x to the negative 7 over x to the 3rd power. And again, I'm going to do this the traditional way because this is the way to get yourself started up to doing this in better formats, right? So we're taking the exponent of the top and subtracting the exponent of the bottom again. Negative 7, take away 3. I'm going to put the negative 7 in parentheses because all negative exponents should be put in parentheses, all right? When you're doing the difference, you could get a sign change if the second exponent is negative. So let's keep that in mind when we're doing this. Actually, you know what? We'll do one of those just after we do this one so we can see the difference of subtracting a denominator's negative exponent. So here we get x to the negative 10, and that becomes 1 over x to the 10th. And what I was just mentioning before is being careful because sometimes your exponent on your numerator could be positive while your exponent in your denominator is negative. And what happens here is when we're rewriting this, we want to put the negative exponents in parentheses because when you have negative negative, it changes to a positive. So then this in all actuality becomes x to the 3rd plus 2, which is x to the 5th. Just keep this in mind when you're doing these differences because sometimes putting these parentheses are going to save yourself a lot of trouble. All right? Let's move on to number 5 now, in which we're going to do this with the second method we did, where we're just moving the term to the denominator based on which power is greater, whether the numerator is greater or the denominator's exponent is greater. And in this case, we know that the denominator's power of 3 is greater than the negative 7. So instead of doing it the traditional way, we'll do the advanced way, in which we're just subtracting from the greater exponent. So this is going to come down and be subtracted from here. And so this then becomes 1 over x to the third plus 7, which is 1 over x to the 10th. And finally, I added one extra special problem that deals with the zero exponent. And this is the case of when we have the same exponent. So when we have the same exponent and we're subtracting them, I'll show you the long way and then the resultant way of what happens here. In the long way, what we do is we take the difference. We get x to the 6th, take away 6, which is just x to the power of 0. And anything to the power of 0, like if you've seen our zero exponent video, gives you just a 1. Besides this notion, we can also understand that when we divide anything by itself, we get a 1. So if I have x to the 6th over x to the 6th, this is always automatically 1 because of the zero principle. All right? Thank you.